Alright folks, you've probably heard of Silicon Valley, but have you come across Silicon Island, aka Taiwan? Our viewers outside Asia might not be too familiar with Taiwan, but it's been getting a lot more global recognition of late. The main reason? It's a pivotal semiconductor manufacturing hub in the world. Take TSMC for instance. They alone produce over half the semiconductors globally. As semiconductors become increasingly vital, tensions are rising between China and Taiwan. The US-China relationship has hit a rough patch, leading to a series of high-tech sanctions against China. This has thrust Taiwan into the global limelight, seen as an island facing significant threats. We're essentially witnessing a semiconductor showdown. In today's video, we're going to explore why semiconductors are becoming ever so crucial, how Taiwan has emerged as the world's Silicon Island, and why TSMC is expanding chip production across different countries. In the midst of this geopolitical tussle, is China set to lose this chip battle? So, let's dive into today's topic, shall we? Alright, let's talk semiconductors, which are materials that conduct electricity under certain conditions, but act as insulators under others. Integrated circuits, or ICs, involve a series of processes like design, photomasking, manufacturing, packaging, and testing to integrate numerous electronic components onto a semiconductor chip, forming a complete circuit system. We'll be focusing on semiconductors in the form of integrated circuits. The first invention of the integrated circuit dates back to 1958 by Texas Instruments, marking a new era in semiconductors. Following this, the U.S. Air Force incorporated ICs into missile design. Texas Instruments and Fairchild Semiconductor launched commercial ICs in 1961, and subsequently, the U.S. Department of Defense and NASA became major clients in the American semiconductor market. Gordon Moore, one of Intel's founders, in a 1975 paper for the Institute of Electrical and Electronics Engineers, postulated that the number of transistors on an integrated circuit would double roughly every 2 years, meaning either a doubling in performance or a halving of costs. This prediction, known as Moore's Law, held true for decades, with semiconductors becoming increasingly powerful yet more affordable. Since the 1960s, with the development of computers, the internet, and various household appliances like electronic toys, washing machines, electric toothbrushes, and in recent years, wireless networks and smartphones, the applications of semiconductors have become increasingly widespread and their importance self-evident. However, what truly elevated semiconductors to a matter of national security was their application in artificial intelligence, high-speed computing, and military weaponry. Take AI, for example. After the launch of ChatGPT by OpenAI, the potential for boosting human productivity is immense, leading many enterprises and countries to prioritize developing their own AI models. AI development requires extensive computations and processing, particularly where GPUs, with their high parallelism, make the heavy lifting of deep learning algorithms efficient. The application of specialized semiconductors, like ASICs and FPGAs, also enhances the efficiency of AI algorithms to some extent. That's why semiconductors have become one of the most critical strategic materials for countries, even being incorporated into national development goals. And this is precisely why Taiwan, the Silicon Island, has found itself in the eye of the global storm. Right, let's get into some numbers. According to TrendForce in 2023, Taiwan held about 26% of the global semiconductor market share, with a whopping 46% in foundry manufacturing alone. TSMC, just by itself, commands a 56% share in wafer foundry manufacturing, and for advanced processes below 7 nanometers, it's over 90%. That's a staggering dominance, folks. To put it in perspective, OPEC Plus has about 60% market share in the oil sector, and that's spread across various countries. TSMC alone hits 56%. So how did Taiwan and TSMC pull this off? The semiconductor value chain mainly consists of 3 parts: design, manufacturing, and packaging, testing. Initially, most American companies like Texas Instruments were integrated device manufacturers, IDMs, handling all 3 functions and leading the value chain globally. However, manufacturing and packaging testing required hefty capital investments. Consequently, many chip companies shifted these functions to Asia, to countries more aligned with the US like Japan, South Korea, Hong Kong, and Taiwan. Taiwan seized this opportunity. Under Minister Sun Yat-sen's leadership, Taiwan decided to develop its semiconductor industry. This led to the establishment of the Industrial Technology Research Institute and a tech transfer collaboration with the Radio Corporation of America. In 1977, ITRI's Electronics Research and Service Organization set up an IC demonstration factory. When Morris Chang took over as the head of ITRI, he transformed this experimental facility into a professional foundry, leading to the establishment of Taiwan's Semiconductor Manufacturing Company, TSMC, in Hsinchu Science Park in 1987, focusing solely on foundry manufacturing. This model emphasized Taiwan's manufacturing strengths. TSMC took on manufacturing contracts from semiconductor design firms, catalyzing the industry's shift towards vertical specialization. Taiwan's packaging, testing, and IC design sectors also flourished. With the increasing complexity and investment in foundry processes, TSMC's annual capital expenditure is now between $30 billion to $40 billion. TSMC gradually secured its dominant global position. Apart from government initiatives and corporate strategy, another key to Taiwan's success in semiconductors was talent development. The Taiwanese government invested heavily in R&D and educational training related to semiconductor technologies. Establishing specialized tech universities and research centers, they cultivated a pool of technical professionals, driving the development of Taiwan's entire semiconductor ecosystem, thus cementing its unique position in semiconductor manufacturing. Semiconductor industry, with its vertical specialization, has led to oligopolies or even monopolies in many of its value units. For instance, there's TSMC from Taiwan in foundry services, ASML from the Netherlands for high-end lithography machines, Synopsys and Cadence from the US for electronic design automation, EDA, Japan for semiconductor raw materials. This specialization has propelled various countries to the forefront of semiconductor technology in their unique domains. In a globalized era, this wouldn't pose a problem. Even if a country doesn't develop its semiconductor industry, it can still buy the chips it needs through international trade. China's a prime example of this. Being the world's factory, China produces a significant portion of the world's electronics, creating a massive demand for semiconductors. In the past decade, semiconductors have frequently topped China's import list, even surpassing energy sources like oil. China, however, doesn't want to remain dependent. Hence, it's been aggressively pushing for self-sufficiency in semiconductors. According to the Made in China 2025 plan, China aims for a 70% self-sufficiency rate in semiconductors by 2025. But the trajectory changed with the US-China trade war initiated by former President Trump in 2018. The relationship between the US and China has since become tense, with China accelerating its push for semiconductor independence. Under President Biden, the US has imposed even more restrictions on China's high-tech and semiconductor development. This includes prohibiting American firms from selling certain chips used in high-speed computing and AI to Chinese companies, and restricting foreign companies using American equipment from selling to China. The US has also pressured the Netherlands to prevent ASML from selling its high-end lithography machines to China. Morris Chang, the founder of TSMC, once commented, "Globalization is almost dead. Free trade is almost dead." Undoubtedly, these measures aim to slow China's catch-up in the semiconductor sector, thereby delaying its progress in military AI and space satellite industries. Amidst these geopolitical developments, Taiwan, due to its sensitive political status and crucial role in the semiconductor industry, has become a focal point of global attention. China has always claimed Taiwan as an inseparable part of its territory. Combine that with Taiwan's pivotal role in the semiconductor field, and the US restrictions on China's development in this sector. There's a school of thought suggesting that China might invade Taiwan in the coming years. This move could be seen as completing China's unification mission and securing a vital strategic resource in semiconductors. Even Warren Buffett, due to potential geopolitical risks, sold Berkshire Hathaway's shares in TSMC. On the flip side, some argue that Taiwan's semiconductor resources act as a silicon shield. This idea was proposed by Australian journalist Craig Addison in his 2001 publication, Silicon Shield. He believed Taiwan's semiconductor resources are so crucial that if China were to invade, Western countries would intervene to protect Taiwan's semiconductor industry, similar to how the US-led coalition protected Kuwait's oil resources during the 1990 Iraq invasion. So, which of these theories is more likely? In our view, the Silicon Shield theory does hold water. However, its effectiveness might diminish as TSMC begins building factories in other countries and operating them successfully. We can glean more insights from TSMC's interactions with various governments. Take Europe, for instance. The EU Chips Act, effective from September 2023, aims to boost public and private investment to achieve a global market share of 20% in chip production for the EU. Meanwhile, in the US, while restricting China's semiconductor industry, the CHIPS and Science Act was introduced to bolster American semiconductor development. Apart from promoting their own semiconductor industries, these countries are also wooing TSMC to set up foundries on their turf. Confirmed locations include Arizona in the US, Kumamoto Prefecture in Japan, and Germany in Europe. Chris Miller, the author of Chip War, suggests the US's encouragement of TSMC to build factories there isn't just a business move. It's more about national security and defense concerns. For TSMC, setting up factories globally is not the most efficient production strategy, indicating political considerations or pressures rather than purely commercial ones. This also implies that if TSMC remains in Taiwan, the Silicon Shield effect could indeed compel other countries to protect Taiwan and its semiconductor industry. The semiconductor industry, driven by these global dynamics, is moving from a globalized, specialized division of labor to a more regional self-sufficiency approach. As TSMC's founder Morris Chang said, globalization is almost dead. Free trade is almost dead, indicating a potential decline in Taiwan's importance in the semiconductor field. So, will China attack Taiwan for semiconductor resources under the US technology blockade? We believe it's unlikely in the short term. Robert O'Brien, the national security advisor under Trump, once stated that if China were to successfully occupy Taiwan, the US would destroy Taiwan's semiconductor industry to prevent it from falling into Chinese hands. Therefore, even if China were to attack Taiwan, it wouldn't be for semiconductor resources, as they are well aware that even with control over Taiwan, they wouldn't get an intact, functioning semiconductor industry. Attacking Taiwan in the short term would also face resistance due to the Silicon Shield effect. However, if TSMC's foundries in other countries operate successfully, China might reconsider an attack on Taiwan in the future, as Taiwan may no longer have long-term support from other countries, with key semiconductor manufacturing resources already established and secured globally. So, how long can Taiwan maintain its position and the Silicon Shield effect in the semiconductor industry? This is likely to be a significant issue in the semiconductor industry and East Asian geopolitics in the future. Right. So the big question is, will China lose this chip war? Considering the current US restrictions on China's advanced semiconductor processes, there's no doubt China's semiconductor development will slow down significantly. But how long this delay will last is uncertain. It could be 5 years or even 10. This is under the assumption that Moore's law continues to advance, and the US or other countries maintain their lead in relevant technologies. Otherwise, the gap might start to close. An important point to note is that the US hasn't imposed restrictions on mature processes, and we've already seen China expanding its capacity in mature semiconductor processes and buying up unrestricted machines and chips in large quantities. For instance, ASML's revenue from China in the third quarter of 2023 accounted for over 40%. So, China might gradually dominate the market for semiconductors with mature processes in the coming years. While the market generally focuses on advanced semiconductors, we've recently seen Huawei, under US sanctions, still launch new smartphones and even venture into electric vehicles. In theory, it's possible to produce 7-nanometer chips for smartphones without advanced lithography machines, but the yield might be poor, and the performance might not be up to par, like being power-hungry or prone to overheating. And crucially, they could be expensive. However, for China, the yield rate or cost might not be as critical. What's more important is having the capability. If China solidifies its footing in mature process semiconductors, it will have more resources to advance to more sophisticated processes. It could also scale up and nurture its own equipment companies and raw material suppliers. This is a privilege of having a vast domestic market. We've seen China evolve from a laggard with poor yield rates and high costs to a market leader in industries like panels, LEDs, and solar energy. Although semiconductor technology is more complex and faces more restrictions, historical patterns make it hard to assert that China can't replicate its past successes. Recently, there's even been talk in the US Congress about investigating China's mature semiconductor products. This situation somewhat mirrors the post-industrial revolution era in Britain. Despite laws against exporting workers and machinery, the Industrial Revolution eventually spread worldwide. Sanctions can be effective, but continuous technological and productivity advancements in leading countries are key to maintaining national competitiveness. In today's video, we've explored how Taiwan, through government support and private sector efforts, has become a global leader in semiconductor manufacturing. With the rapid development of technologies like artificial intelligence, the importance of semiconductor manufacturing is only increasing. However, amidst the ongoing tensions between the US and China and Taiwan's unique position, Taiwan's leading semiconductor manufacturer, TSMC, has been setting up manufacturing bases in the US, Japan, and Germany. The political motivations behind these moves might well outweigh economic considerations. In this geopolitical climate, the US continues to impose sanctions on Chinese high-tech, while China expands its mature process capabilities in response. It seems like the chip war is just beginning. So, after watching today's video, what are your thoughts on the development of semiconductors and the corresponding geopolitical changes? Do you think China will lose this chip war? Or might China go to war over semiconductor resources with Taiwan? Feel free to leave your comments below and join the discussion. See you in our next video.